Wait, who are you again? You should remember me. I'm a clone from the other video, remember? You. Do I?
Hello and welcome lads and lasses. Bro.
Oh yeah, I do remember you. I thought I locked you up in the cage.
Yeah, I don't care about me being in the cage here. I'm here failing my GCSEs, end of year, end of term, end of year. And my parents are up there getting the whip, slapping my bum, it's already red and all that. And I can't handle the torment anymore. I need your videos to actually save my life and save my education. I don't want to be working at McDonald's here. So please, can you?
As much as I do care about you passing your GCSEs, but I just can't be asked right now.
Oh, you can't be asked. No, Mr. Nice Guy, yeah? I'm gonna go Batman, man. Just
wait. Where are you going?
Yeah, I got
okay, chill. Chill. You can put the knife away. I'll go record right now, yeah. Just calm down.
No, bitch.
Yeah, I'm in my PJs. I wasn't prepared for this, but yeah, I got you.
Hello and welcome lads and lasses to another video. My name is Tammy Chowdhury, aka Dr. Chowdhury, the only doctor without a PhD. This video is going to be all about maths and factorizing quadratics. And yes, I've been off for such a long time. If I can recall, 2 months ago was my last video, but obviously that was because I was busy and yeah, and the line's kind of off because this light thing doesn't work. Other than that, let's get right into the video, innit? Now, what is a quadratic equation? Quadratic equation is normally where there's 2 x's involved, or you can have more, but then obviously the like terms of x will collect, but there's a squared, and that's the highest power it can be in an equation. If the squared is the highest power, it makes a quadratic. If the highest power is a cube, it's a cubic, and then 4, it goes on and on and on. Then yeah, the reason why we factorize quadratics, I actually don't know. We have to just do it for our GCSEs. To get the 9s and 8s you need for your GCSEs, I want to teach you how to do a quadratic equation and factorize it, like this one here. Now, first thing you have to realize is when there's no number in front of the x squared, it's normally just a 1. So it's important to know that rule, because when we factorize quadratics, we always need to multiply the coefficient of x squared, which is the number in front of it. So 10 is the coefficient of x already, and then multiply it with the last number, which is not the x term. If 10x was here, you don't multiply 10x, always multiply the coefficient of the x squared with a number that is not next to an x at all. So 1 times 21 is 21. Now, once we're in this stage, we need to find 2 numbers when multiply each other, get 21, but they add to get 10. So we can list out all the factors of 21. So there's 1 and 21. But if you do that, you can't get 10. It's impossible. You can't get 2 because it's odd number. Let's do 3 and 7. Oh, so if you do 3 times 7, we get 21, and if we do a plus in between, you get 10. So the 2 factors we can get is 3 and a 7. So then we go into our next stage. I'm gonna rub this out. So yeah, always write out your factors if you want to find this. We break this down into these numbers, but obviously we're gonna write x there next to it. We're essentially breaking this down into 2 smaller numbers that can actually work with the equation. So we could do x squared plus 3x plus 7x plus 21. Now we can basically we basically take the 2 as its own. That should be 7. Hopefully that does not look like 7. Yeah, so we got the 2 brackets itself. So we basically wrote x squared plus 3x plus 7x plus 21, but we basically got it separately of each other. And I don't think you see my face for most of this, so my apologies. So yeah, we factorize this part out first. How do we factorize? We look for what's the most common value in here. So we can see so that's basically saying x times x, so there's 2 lots of x's there, and there's an x there. So I say we can take x out as common, so we do x out, x plus 3. or if you don't understand what I'm doing, or whenever it's x squared plus 3x and there's no coefficient, just take out the x and then just write x there, because x times x is x squared, x times 3 is 3x, so yeah. And then we go to the next one. We could take, so we got 7x plus 21 right here. We could take out the 7 out as common because it's the highest multiple here. There's no x's in both the things, so we can't take out x, we can just take out 7 outside. So 7x divided by 7 is an x, because if we do that it cancels out. 21 divided by 7 is just a 3. Now the one way to determine that you actually did it correctly is when these two brackets are the same. If these two brackets are the same, you've done it correctly. Well done. But then we still have one more step. So we have to take out what's common again in this equation. This is 2x plus 3's. We just make x plus 3 its own bracket. And then we just take the x plus 7 in its own bracket. Done. We factorized it. And if you want to check it, you can multiply it out. So that's going to be x squared plus, oh god, that's true, x squared plus 3x plus 7x plus 10 plus 21. And yeah, that is the truth, but it's going to simplify to x squared plus 10x plus 21. Now what happens if we meet an equation with the coefficients not 1 but 2? Well, same rules apply, so let's move on swiftly into the equation. Yeah, so you do the coefficient of 2 times the minus 5, and remember that whatever sign is next to the number always belongs to the number. So if there was, like, let's say if this was a plus 5, it will be a positive 5. Since it's a minus 5, it's basically saying negative 5. So positive 2, because there's no sign there, so it's obviously positive, because you don't put a number that's positive with a positive sign unless you're adding. So you do 2 times minus 5, which is minus 10 right here. Then you find two factors that multiply to get minus 10, but add to get minus 3. We could do 1 minus 10, and we'll come on so it doesn't confuse people. Minus 1, 10, 2, minus 5, minus 2, 5, and yeah, I think those are most of the factors. So yeah, now we look for a list and find out which factors times to get minus 10, which obviously all of them do, but add to get minus 3. So 1 minus 10, that's minus 9, minus 1, 10, that's positive 9, 2 minus 3, 2 minus 5, that's minus 3. Bingo, we got our factors. 2 and a minus 5. So since we know our factors, I'm just gonna write this all out. Now there are two methods you can do. You can do a grid method or the method I showed you previously, but you can apply it to this one. Now let me show you two methods you can do, the grid method or the methods I just did. I'm gonna do the method I just did before, because else I could do it more quickly. So since we know the two factors of thing, I could just do 2x squared. And since this is an even number and the other factor we got was even, I'm just going to put the even factor next to it. It makes it easier to when I factorize. So minus 2x, no, it was a plus 2x actually, because the factor was minus 5 and 2. And then I'll do a minus 5x minus 5. Alright, now obviously put them in their own two groups, including the positive sign. I didn't do that the other time, which was a mistake. What can I take out here? The 2 is common, as well as the x, because they appear in both. So that's going to be 2x, x plus 1. Here I could take out the minus 5 as common, do x plus 1. Now, what did I say before? Always check that these two brackets are the same when you factorize. So since they're two same, since both of them are the same, we've done it right. So then we just bring the 2x and the minus 5 in its own bracket, with this as its singular bracket. And there we go. We've done it. Factorize the coefficient, which is 2. And the same rule applies with more than 2, so 3, 4, 5, 6. The equation should work. Yeah, you would never need to use a calculator in these type of equations, apart from these ones. Yes, I know. That definitely does look like a scary equation. Such big numbers. I've never seen them before. But there is something called the quadratic formula that can actually help solve this very quick. I haven't tried if this equation works, because sometimes the discriminant sometimes leads to x roots not being involved. That's for a later video, so you don't have to worry about this. So the quadratic formula is essentially derived from ax squared plus bx plus c. As you can see, a is 52, b is 25, c is 216, and you can rearrange this equation to get x on its own, which I'm not going to go through because you need to know some other things, which is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be the formula you're going to be used for these very big equations. It makes it all very quick, and so you basically plug in minus, then you put the brackets in your calculator, 25, and then you do plus, so you can either do it plus or minus. So you can start with plus, so plus the square root, then you put brackets 25 squared minus 4 brackets 52 brackets 216 over 2 brackets 52. Once you've done that, you do the next one. So if you did plus, you do a minus next, and if you've done a minus, you do plus next. And then you should get two solutions for x. They can both be negative, they can both be positive. It depends on how the quadratic graph looks like. So you can have sometimes two positive values, you can have one positive, one negative, you can have two negative. It depends on how the graph looks. Gia will teach you how to draw quadratic graphs in a later video, but that's all you should know for quadratic factorization. Thank you guys for watching, and hopefully that I do not go anywhere or make fake excuses on not uploading. I'll see you next time.